Okay, so let's review exponent laws. First one, the product law. When we have the same base being multiplied, 1 second. Same base is being multiplied, what do we do with the exponents? Add them, so m plus n. Let's go over to the quotient law. Quotient, I can't speak today at all. Same base is being divided, we would subtract m minus n. Power of a power, so if you have a x to the power of m, all to the power of n, multiply m times n. Maybe I will zoom in. It's kind of hard to see. Power of a product, this exponent of m applies to everything inside, so both the m and the y. And if there was a coefficient, it would also apply to the coefficient. Okay, same idea with if division. This exponent of m applies to everything inside. Make this y smaller. If you have a negative exponent, what does it do? Flip it. We put it on the denominator to make it positive. So 1 over x to the power of m. And last, if you have an irrational exponent, it's the same thing as a radical. The nth root of x to the power of m, or the nth root of x all to the power of m. Same thing. You will not be given this on your test. You need to know these laws. Okay? Just need to know how to use them. And really, there's only two new ones, but they're tough, right? So we're mixing them all together, which makes it kind of hard. So we're going to practice what we learned on Friday some more, which is good practice. So let's go through these examples here. So the first one, write each as a radical. Each power is a radical. Okay, so 6 is the power or the index? The index. 6th root of x to the power of 1. Do you have to write 1? No. Okay, so my question for you here in this next one, does the 5/4 apply to the negative? This is the exponent of 5. No, it's just applying to y because there's no brackets. So the negative's going to stay on the outside when we change this to a radical because there is no brackets. And it would be the 4th root of y to the power of, it's hard to read that, 5. Good. And the negative's on the outside. Whereas C, is the negative go inside the square root this time? Or the whatever root we have? Sure does. Okay. So this would be the index, 3. And because it's a negative, I want to keep it in brackets inside. Okay? Because we're still raising it to a power. What's the power? 5. Now, theoretically, we could get rid of that bracket because if you have an odd exponent, a negative number to an odd exponent, it's still going to be negative, right? So because this is odd, you could also write this as, in this case, negative z to the power of 5 without the brackets. Make sense? Okay. Where would I start with D? Negative exponent. You see a negative exponent, we want to deal with that first. Oh yeah, it's my yellows. Let's try this one. Sort of. I don't know. I give up. There we go. The negative exponent, we need to take care of that. So in order to, if we have a negative exponent, we move everything to the bottom. And now the exponent is positive. And we're left with 1 on the numerator. There's nothing else. Okay? So you can write that instead as, what's the index? 3. So cubic root of negative z to the power of 5 would be your answer. So what's the difference between E and F? What's the difference between E and F? Okay, one has brackets, meaning, yes, Caleb. Okay, so in E, the 5 is not included inside the radical, whereas in F, it would be inside. Because the exponent is applying just to the t here. There's no brackets. Whereas this time, the exponent's applying to both because of the brackets. The 5's left on the outside. Now, what would be my index? 4 t to the power of 3. So again, the index would be 4 here, and the 3 on the outside. But notice how I have to keep those brackets, because the exponent cube, that's applying to the 5 as well, right, to everything inside. Unless you want to put the cube on the outside, then you don't need the brackets. Okay. So let's work with some fractions, because I know you all love fractions. It's your favorite thing. I don't know why there's such a fear of fractions. They're funny. Don't be afraid. Really? It's not good. They just told you, just put it in a decimal? Oh, wow. But then you don't get good at your fractions. Okay, simplify the following. Write each expression as a power with positive exponents and then as an entire radical. Okay, so same base being multiplied. So I wrote a little 1 there, right? Why would I write a little 1 there? If you don't see the power, good, thank you, it's 1. We have the same bases being multiplied. What are we going to do? Add them. We're going to add them. So let's do some review of fractions. We can use our calculator. Yes, I know. I know you could take your calculator and go 3 over 2 plus 1. And then if I want that as a fraction, what would I push? Math, enter, enter. Oh, beautiful. 5 over 2. There it is. Okay, so how do we get 5 over 2 from not using our calculator? Don't know? Okay, let's review. If you have 3 over 2, and we're adding 1, we need to turn 1 into a fraction. How do I turn 1 into a fraction? Put it over 1. In order to add fractions, what do we need? The same, oh, that's not a highlighter. The same denominator. We need the denominators the same. So we're going to multiply top and bottom of the second fraction by 2. So you need to make the same denominator. Would you agree that 2 over 2 is the same thing as 1? Yeah. So now when you add fractions, we add the numerators. Do we add the denominators? No, we leave it the same. So 3 over 2 plus 2 over 2 is 5 over 2, which is what your calculator gave you. Good times? Okay, I'm going to erase that. Same bases being divided. What are we going to do with our exponents? Subtract 1/3 minus 5. Oh, I didn't finish the question. Sorry, I'll go back to A after. 1/3 minus 5/3. Negative 4 over 3. It wants me to answer with positive exponents. So how do I make that a positive exponent? Reciprocal or flipical. What else does it want me to do? Right, as a radical. So I should have done that with this last one too. As a radical, square root or fifth root? Square root, the bottom, right, is the root, is the index. So square root of x to the power of, and the top is the numerator is your power. 5. No, it's good. So this letter B, fourth root or cubic root? Cubic root. The denominator is the index. Y to the power of 4. The numerator is the power. Notice these are all fractions. Yay. Okay, power to a power, what are we going to do? Multiply. How do we multiply fractions? Yeah, multiplying is the easiest part. I love multiplying. It's so easy. Straight across. Easy. 1 times 2. 2. 2 times 3. 6. Does that reduce? 1 over 3. So a to the power of 1/3. And as a radical, would the index be 1 or 3? Are you ever going to have an index of 1? No, it's not possible. So cubic root of 8. Hey! Okay. What's the first thing you need to take care of here? The negative. Okay. So if I have a negative exponent, okay, how do I, in this case, if it's a fraction, how can I make that a positive exponent? How can I make this positive 1/2? That's not the that's for bottles. Do what? Come on, guys. Flip it. It's under my. Okay, the 1/2 applies to everything inside, so let's apply it to both. Power to power, you're going to multiply. What's the exponent on y if you don't see it? 1. So it becomes y to the power of 1 times 1/2. 1/2, or not 1/2. 1/2. Just 1/2. 1 times anything is itself. Good. Over 2 times 1/2. What's 2 times 1/2? Nope. Come on, guys. 1. 1/2 of 2 is 1, right? 2 times 1/2. 1/2 of 1, or 1/2 of is yeah. Yes. Exactly. That's said much better than I did. Okay. It's 1. So we only have to change who to a radical. Who do we have to change? Just the y. It's going to be, what's the index? 2. Do you have to write that? No. So square root of y divided by x. And we don't have to write the power of 1 either for the y. Can we, if you want to, like right here? Yeah, you're welcome to put the index in if you want. Yes, so we did 1/2 times 2/3, which was equal to 1/3, is what we did. Okay. Oh, should I wait a second? Got it? Simplify the following. Write each expression as a power with positive exponents and then as an entire radical. So same idea here. Where would I start with this? You could like move the negative exponent to a denominator. Do we have the same bases here being multiplied? So if you want, you can also go straight to adding them. But you have 2 coefficients. What are you going to do with these 2 coefficients? Multiply. So 4 times 3 gives you 12. And then 3/4 plus negative 1/2. We need a common denominator, right? Yeah. So if you had 3/4 plus negative 1/2, how do I change this out of to the denominator to be a 4? Multiply by 2. So negative 2 over 4. 3 plus negative 2? Negative, no, not negative. Positive 1 over 4. Now, could you use your calculators? Yes. 3 divided by 4 plus negative 1 over 2. No, it doesn't apply to the 3. It just applies to the x. Is that what you're asking? Because there's no brackets here. So it's just to this. Otherwise, if it was, like if there was brackets there, then we would be forced to flip it so that we can evaluate the number. 0.25 or math, enter, enter. 1/4. Yay. Okay. Now, somebody said flip, and you could have, right? So I'm just going to show you, I don't know where, somewhere else. If you had, we had 4 and 3 x to the 3/4 times 3 and x to the negative 1/2, right? I hate using times, it has to be a dot. There you go. So you could have flipped. Now, when you flipped, are you just flipping with the negative exponent, just the x or the 3 as well? Just the x, because that negative exponent, it's not a brackets there, it's only applying to the x. That's the power of 1/2. It doesn't really look that way, does it? So move it to the denominator. You could have done that. Now, when you multiply with fractions, I would need to make this over 1, right? So then I can go straight across, which gives me 12x to the 3/4 divided by 1 times, well, it's just 1. You don't have to write the 1. X to the 1/2. When we have the same bases, what are we doing? Subtracting them. So 3/4 minus 1/2. Notice if you look at this and you look at what we did here. When you subtract 1/2, is that the same thing as adding negative 1/2? Yeah. Right? Adding negative 1/2 is the same thing as subtracting 1/2, which is still going to give you the same answer of 12x to the 1/4. Which one seems easier? Yeah, the first one. So if you can, if we go straight to add using my exponent laws of adding, let's do that, because that might eliminate the negative right off the bat. Well, you're welcome to do this. You still get the right answer. We still get 12x to the 1/4. Okay, same thing. Now the question asked me to write it with positive exponents and then as a radical. Does the 12 go inside the radical? No, there's no brackets. So it's 12, and then is it, well, index is 4, 4th root of x. Okay. Okay, B. What could you do in B? There's a few ways we can approach this. What's your first instinct? Divide, so just go straight to division? Sure. So let's do our coefficients first. 5 divided by 25. Does 25 go into 5? Not really, but can it be reduced? 1/5. So when you divide 5 by 25, it's going to give you 0.2, or math, enter, enter, 1/5. So my coefficient will be 1/5. We divided those two, right? We reduced those. When we're dividing the x's, we have the same base. What are we going to do with our exponents? Subtract. So we're taking 3/5, and what are we minusing? Negative 3/5. So you have to be very careful here. Because when you subtract a negative, what happens when you, well, you can use your calculator if you want, and then we'll talk about it. So 3/5 minus, 3/5 minus negative 3/5. That. 1.2 or 6/5. Did you get the same thing? Which makes sense, right? Because if you're subtracting a negative, it's the same thing as adding a positive. And if we add our fractions, we have to keep the base the same, add the numerators. 3 plus 3 is 6/5. Oops, that's not what I wanted to do. Where's my eraser? Okay. Now, does the 1/5 go inside the radical? No. So it'll be 1/5. And 5th root or 6th root? 5th root of x to the power of 6. Okay. Now, on a side note, you could have approached this a different way. I'm going to show you. You might have done this. So if you saw a negative exponent, what could you do with that negative exponent? Move it to the top, and you could have done that. Okay? So I could have said, okay, this has a negative exponent, so I'm going to move the negative exponent to the top so it becomes positive. Oh, that's green. 3/5, and then we have another x to the 3/5, and we still have 25 on the bottom. Okay? So same base being multiplied, what would you do with your exponents? You would add them, so it becomes x to the 6/5. And then 5 over 25, can we reduce that? 1 and 5. So you could, if you want, to write 1/5, or you can write 1/5, x to the 6/5. So that would work too. So if your instinct is like, I want to get rid of that negative exponent first, you can. You can move it up. Only this would move up. 25 doesn't have a negative exponent. It's not in brackets. And then combine them. Okay? All right, so we're going to do one more, and then we're going to take a break, and you're going to do some work. I like this one. Where do I begin with this? Any ideas? Okay, you want to multiply? Yeah, your exponents, because they're the same. The 4/3, who does it apply to? Everything, including who? The 8. So the 8's going to become 8 to the power of 4/3. It applies to everything inside. The exponent on 8 is a 1, right? Oh, that doesn't look like a 1. It's a 1. Ugh, what's going on with you? Try again. There we go. So 1 times 4/3 is 4/3, right? For multiplying exponents. And 8 to the power of a half times 4/3. We multiply those two. You get 2/3, right? 4/6 or 2/3. 8 to the 2/3. Okay, so we actually want to evaluate the number. We can evaluate that, right? 8 to the power of 4/3 is the same thing as, is it a 4th root or cubic root? A cubic root of 8, and then to the power of 4. What is the cubic root of 8? 2. 2 to the power of 4 is 16. 2 squared is 4. So you have 2 squared times 2 squared. 4 times 4, 16. So instead, we can write this as 16a to the power of 2/3. Who's going to go inside the radical? Just a. The exponent is only applying to a. Square root or cubic root? Cubic root, a to the power of 2. So we're going to take a little break. I'm just going to pause the movie. And what you're going to do, I want you to... So what I'd like you to do is for number 4, right now, write each as a power. So it's a radical. Let's go the other direction. Write it as a power. I'll do the first one with you. A to the power of power over the root, 5 over 3. Okay, you try B, C, and even D. Review, right? A to the power of 2 over 5. A to the power of 9 over 2. If you don't see the index, it's a 2, right? That tricky little square root. So careful with C. Now D, they want us to write in the form of a to the power of n. So we'll start as writing it as 1 over a to the power of 7 over 2, power over the root, right? And then we want to write it as a to the power of something. So to move it to the numerator, what's going to happen? It's going to be a negative exponent, negative 7 over 2. So we're moving it to the numerator. To move it to the numerator, the exponent becomes negative. Yeah. Here to here? Yep. Absolutely. Okay, this will be new, the next step. Well, yes, applying what you know to a new situation. That's what it'll be. Write as a power and then evaluate. So remember from last Friday, square root of x can be written as x to the power of what? What's the power if you don't see it? 1. The power. What's the index if you don't see it? 2. So 1 over 2, right? The square root of x is the same thing. Square root of x is the same thing as x to the 1/2. Because your power is 1 and your index is 2. We covered that on Friday. Okay? So, if we first deal with the inside, this inside square root, instead of writing it, not what I wanted. Instead of writing that as a square root, how could I write that as an exponent? To the power of, well, let's just do the inside one first. Power of 1/2, 1 over 2. Because square root is the same thing as an exponent of 1/2, right? And this square root is the same thing as an exponent of same thing, 1/2. So we can also put another set of brackets and write that as an exponent of 1/2. Okay, so the inside is the yellow one. So this was the yellow square root, the inside part. And then we had the outside square root. That just looks messy. Sorry. Just trying to show you the difference. Okay, so a power to a power. What do we do if you have a power to a power? You multiply. A half times a half. A quarter. Go straight across. 1/4. So square root, a fourth root, I think I told you this before. A fourth root is the same thing as square rooting twice. Right? And that's why. It's a square rooting twice, the same thing as a fourth root. So it says it wants me to evaluate, so I'd like you to type that into your calculator. Make sure you get the right answer. 1,296, the power of a quarter. Should get. Type that in. You want to make sure, because when you come to your test, if you ask me how to use your calculator, I'd say you had plenty of classes. You've had all of February to ask me how to use it. Right? 6. Okay. So you make sure that when you do your exponent, you might have to put brackets, depending on your type of calculator. Okay. Oops. So this guy, you could write this as 1 over 169 to what power? 1 over 2, 1/2. And how do we move it to the numerator? We make the exponent negative. So 169 to the power of negative 1 over 2. Type that into your calculator. And go math, enter, enter. You're going to need to push math, enter, enter. One over 13. Notice that a negative exponent, it doesn't make a negative number, right? It's making a fraction. That's what negative exponents do. Okay, let's start with writing the square root of 64 a different way. Square root of 64. We can write that as 64 to the power of 1/2. Okay, now let's write the cubic root. The cubic root of 3, how else could you write that? 1/3. So the all to the power of 1/3. If you have a power to a power, you multiply. 1/2 times 1/3, 1/6. So please type that in your calculator. Yeah, perfect. Okay. So let's move on to these ones. These ones are a little bit more interesting because what do you notice it's different with these questions? There's a coefficient inside, okay? So when you have a cubic root, that cubic root applies to who? At both of them, right? So remember when we did radicals? Remember if I had square root of 20, you could write that as root 4 times root 5? Do you remember that? No? Yeah? Okay, so if you have a variable and a coefficient, we can kind of do the same thing. We can split this up to cubic root of 8 times the cubic root of x to the 5th. We're going to split it up because we want to cubic root everything inside. Can you take the cubic root of 8? It's a perfect cubed. What does it equal? 2. Can we write this as an exponent? Can we write this as an exponent? So what would be the power? What would be the root? Exponent of what? 5 over 3. Okay. Do you want to try B on your own? Split it up. Evaluate the coefficient. Write the variable with a fractional exponent. What is the 5th root of 32? Do you remember how to type that in? You have to push the 5 first, the index first, math, number 5. So 5th root of 32 is 2, and this should be x to the power of 3 over 5. So let's split up these two. Root 900 times root x. What is the square root of 900? 30. How can you write x, square root of x, as an exponent instead? What's the power? A 1. What's the index? 2. Good. I'd like to get these 2 questions done. Okay. B again. So it's a 5th root, right? On your calculator, yeah. You have to type 5 first, then math, then number 5, the xth root. And then you put 32, enter. Okay. Okay, in order to combine these, they need to be exponents, because right now you can't really combine them. So let's write these each as a power. First one would be 5 over 90. We have to make them fractional exponents first. 5 over 3 times x to the 1 over 3. If you have the same base, now what do? Add them. 5/3 plus 1/3. What does that equal? 6/3 or just 2, x squared. Now you could have also, because notice the indexes are the same, right? In this case. So if you wanted to, you could have actually brought them into the same bracket. x5 times x to the 1, only because they have the same index, which is the same thing as x to the 6. And remember when we did radicals, we divided power over root. 6 divided by 3 gives you x squared. So that could have worked too. Okay. That was from the radical portion of the course. Now these guys, do they have the same index? A square root and a cubic root? No, so we have to write them as fractions. Okay? X to the power of, it's a square root, the same thing as. Power is 1, index if you don't see it, 2 times x to the power of, power, if you don't see it, 1 over index of 3. Same base is being multiplied, what are we doing? Adding. What do you need if you want to add those two? Same denominator. So what would be the common denominator we'd make? 6. So to make a half 6, you'd have to multiply top and bottom by 3. We'd have to multiply this guy by 2. So 3 over 6 plus 2 over 6 gives you 5 over 6. Okay, so I'm going to leave it there for today. There's one more example on the next page, but we can look at that tomorrow. The rest of the homework, if you want to get a head start, it's probably a wise decision. Just do some homework tonight. Okay, so the rest of the assignment would be, if you already finished 1 to 3, you're good, because it's 1 to 6 ACE, and then 8 to 16. Tomorrow is mostly work time, so we're going to go through a review of some more stuff, and then just do lots of practicing and mostly work time. Okay? Sounds good? So if you get a head start on this, you'll be in better shape for your test, because then you can bring your questions tomorrow. So anything you don't get, star it, move on to the next question, then we can go through it tomorrow in class. Okay? Yay!